Hello and welcome to Blockchain Fundamental Series. In this lecture, we will be discussing digital signature. So let's start with the person called Alice who wants to transfer money to Bob. For Alice to send money to Bob, she simply broadcasts a message with the account and the amount. So every node that receives it will update their copy of the ledger and then pass along the transaction. If you see here, we have four nodes. So Alice will broadcast a message, and that message will contain the account number of the Alice and the amount. And then let's say, for example, node number one received that message. Now every node, whichever is receiving this message, will update their copy of the ledger. And once the update is done, it will then transfer that message to another node. Now the same process will be repeated again to the other nodes. But here is the main question here. The question is, how can nodes be sure that the request is authentic, that only the rightful owner has sent a message? Now, here the node 1 will ask a question that how I can make sure that the Alice is the person who has sent the message. Bitcoin rules require a kind of password to unlock unspent fund, and this password is called a digital signature. So in the real life example, if you see in a bank, if you want to issue a check, we give a signature in a check. So in the same way, here we have to provide the digital signature. So like a real handwritten signature as we provide in a check, it proves the authenticity of a message, but it does so through a mathematical algorithm here that prevents copying or forgery in the digital realm. Unlike a simple static password, a completely different digital signature is required for every transaction. In Bitcoin, you are dealing with complete stranger. So you never want to reveal a password that could be copied and reused by someone else. Both public and private key purpose is different. So here if you see the digital signature how it is being created. So it is being created using the private key and a message. A private key is used to create a signature. And public key that others can use is to check it, or we can say to verify it. You can think of a private key as a true password. Again, and the signature as an intermediary that proves you have the password. So if signature is created, it means that you have a private key. Without the private key, signature cannot be created. So here to create a signature, we have to use the private key, but along with this, we should not have to reveal the private key to anybody. To spend money, you must prove that you are the true owner of a public key address from where money was sent, and you do that by generating a digital signature from a transaction message and private key. Other nodes in the network can use the signature in a different function to verify that it corresponds with your public key. As you can see here, signature is being created using the private key and a message. So here is the private key and here is the message. The combination of both creates the signature. And in order to verify that, we need signature, message, and the public key. And if this function returns true, it means that this message is verified. So the math behind the digital signature, they are able to verify that the sender owns a private key without actually seeing the private key. So this is all about the digital signature. If you want to know more about the blockchain, or if you want to learn the advanced concept of the blockchain, please refer the Udemy URL given in the description section below. If you find this video interesting, consider getting subscribed. Thank you very much for watching, and I hope to see you in the next video.